Good morning, guys of grade 11. Today, inshallah, we're going to continue what we started yesterday. Yesterday, we started to talk about the solubility process or how the solution process already working. That means what happens when we add the solid, okay, and a solvent, and the solid start to break down in the process of solubility. So yesterday, we discussed the different factors that could affect the rate of solubility or that could affect the solution process. So we talked about the heating the solvent or the temperature, also the increasing the surface area. And then we end at this part, which is the difference between saturated and unsaturated solution. Just to remember what the difference between them, we said that saturated solution, that the solution which the spaces between the solvent particles are completely filled by the small particles of solute. That means already the solid breakdown and fills all the spaces between the solvent, so the solvent cannot able to dissolve any more solid. So like this, we can say saturated solution is a solution in which the maximum amount of solid is dissolved in a solvent. While unsaturated solution is the solution which still have more spaces between the particles of solvent, which allow the solid to keep breaking down or keep dissolving and hiding between these spaces. So that's the just to remember, like the example when we said when you get a cup of water and just add 1 spoon of salt or sugar, it will dissolve easily. The second spoon also may dissolve. The third spoon may not dissolve, and it's still settled down at the cup. Why? Because already the first 2 spoons they completely filled the spaces between the particles of the water, and there is no more space for the third spoon of salt to dissolve. In that case, we said that the salt will settle down and the eye level. It appears to be a static situation, but actually it's a dynamic situation because one particle of the salt down in the cup is dissolving, another one is going to recrystallize or going to reform and settle down. So it's a dynamic situation. We call this the dynamic equilibrium or equilibrium. In that case, that is a saturated solution once the solution reaches the equilibrium state. So that's like this what we said yesterday. Today we're gonna continue. We have something called super saturated solution. So what is super saturated solution? From its name, we could predict that it's a solution which could carry more than its regular capacity. That means it's already saturated, but that is not enough for us, so we needed to make it super saturated, okay? That means we needed to hold more of solid. So how can we do that? If already in saturated solution, all the spaces between the solvent particles are filled by solid. In that case, we just gonna use one of the factors which I said before that affect the solubility, which is temperature or heating. So simply, if you want to make a super saturated solution of sodium acetate, okay, that's the example that we said. We said that sodium acetate is going to have a 46.4 gram for each 100 gram of water. That is the saturation. What if I need that 100 gram of water to dissolve more than this 46.4 gram of sodium acetate? In that case, once we reach the equilibrium, that means the solution becomes saturated already, we start to heat up, okay? Heating the solvent. By heating up, it makes the solvent, the water, okay, particles start to move faster and somehow expand, move further away from each other, which provide extra spaces that could allow extra amount of sodium acetate to break down or to dissolve and hide in. In that case, the solvent will carry out of this 100 gram of water will carry more than 46.4 gram of sodium acetate. So in that case, it carrying more than the normal saturation level. We call it super saturated. But the problem is once the water cool down again or just stop heating, the water okay will cool down and that will make the particles back again to its normal position and the sizes or the spaces between the particles of water will turn back to the normal. So the extra amount of sodium acetate which is already dissolved is going to recrystallize again and fall down at the bottom of the cup. So here like this, so super saturated solution that just kind of solution that you made by heating the saturated solution to make it able to dissolve more solid. Okay. So here like this, guys, we know what difference between unsaturated, saturated, and supersaturated solution. Okay, now we're gonna pass to another part, which is solubility levels. So scientists that start to observe the different substances they could dissolve in different amounts in the solvent, okay, or in the same solvent. It means if I have water and I start to dissolve different substances, salt, sugar, blah blah blah. So I'm gonna do the water will carry, or this amount of water will carry the same amount of each substance. Actually, not. They allow that's depend on the size of each particle, or depend on the size of the substance which dissolve. Okay, so because we know, so for example, the ions are smaller in size than other ions, or maybe than other atoms, or maybe than other some more compounds and so on. So like this, they will not be the same amount. So like this, we have something called solubility value. It means the substance, or the solubility of substance in amount of that substance required to form a saturated solution. That means how much, okay, the certain amount of solvent could carry, or the maximum amount that could carry by a certain amount of solvent of a certain substance. Let's take an example to understand here. So this table, for example, here represent the idea. First of all, once we just count solubility, or to find the solubility value, we need to fix some factors. First of all, the amount of solvent must be constant, and the temperature to be able to compare between the solubility value of different substances. Let's take an example here. If we're going just we have 100 gram of water, so this 100 gram of water we gonna try to dissolve silver nitrate, barium hydroxide, and that's glucose, for example, and calcium hydroxide, uh, says here, so potassium chloride, potassium iodide, potassium nitrate, lithium chloride, blah blah, different chemical substances. As you can see, even carbon dioxide and oxygen as gases. So we try to dissolve them in water. So we're gonna find, for example, 100 gram of water at 0 degrees Celsius. It could allow 122 gram of silver nitrate to dissolve. That means it will be saturated by dissolving 122 grams of silver nitrate. The same 100 gram of water just allow 73 gram of sodium nitrate only. Okay, while it's allow 0.335 gram, okay, of carbon dioxide. So in that case, it represents here, or the amount, or the soluble value depend on the type of the substance itself. So it varies, and of course, by increasing temperature, as you can see here, you could observe that the rate of solubility increases, okay, because as we said, the particles move faster and the spaces become bigger between water molecules, which allow more solubility. So here, like this again, so soluble value, it depends on type of the solute, and we should, in that case, to compare between the solubility values of different solutes, we should fix the amount of solvent and the temperature to ensure that the comparison is accurate. So here, like this, guys, we pass to solute solvent interaction. This is, what does it mean by solute solvent interaction? We have a big question. Do all solutes dissolve in any solvent, or vice versa, the other side of the question? Does any solvent able to dissolve in a solute? That's a very big important. That means, imagine if you have some oil, could it dissolve in water? So I think the answer is gonna no. While if you could, can you dissolve salt in water? So yes. So we are gonna say, in another hand, could you dissolve, for example, oil in, for example, ether, or just dissolve it in toluene? It's yes, but it cannot dissolve in water. So which means some solids could dissolve in certain solvents. Okay, not all solids could dissolve in all solvents, and vice versa. So here in that case, it represents the idea. It depends about the interaction between the solid and the solvent. So some solutes are able to dissolve in certain solvents based on the structure of the solid and the solvent. So simply in that case, we're going to find that most ionic solutes, okay, that means that, so if the solid is already made of ionic compounds, that means and ions are already bonded to each other by ionic bond, they easily to dissolve in polar solvents. Okay, that means the solvents which somehow carry partially charged particles. Okay, so that means they can gonna dissolve easily, while they cannot dissolve in covalent solvents. And also the opposite. If we have covalent compound, sometimes they do not dissolve in the water, okay, or in polar compound. Let's clear the idea here, guys. What happens, okay, when we dissolve ionic compounds in aqueous solution? Aqueous means water, okay? So that's a little word, aqua means water. So dissolving ionic in aqueous solution. Once we get ionic compound like sodium chloride or lithium chloride and just add it in cup of water, what happens? So lithium chloride crystals look like that. It's made of chlorine atoms, these big red, big green circles, and lithium ions, which is actually made of these purple circles. So we just place it in cup of water. The cup of water contains a lot of water molecules, as you could observe. This one, the Mickey shape, okay, H2O. So what happens here? As we know, polar water is a polar compound, which means it has unequal electronegativity between hydrogen and oxygen, which makes the oxygen is partially negative while the hydrogen is partially positive. Regarding that, we're gonna find that the partially negative oxygen of water is gonna attach or attract it to the negative ion of chlorine, and the positive part of hydrogen, the partially positive hydrogen in the water molecule, they will be attracted to the positive, to the negative chlorine, sorry, and the negative part of oxygen in the water is going to attract to the lithium. And due to the continuous motion of water, the water will hold or attach. Here, the attraction force between the partial negative oxygen in water and the positive lithium in lithium chloride is higher than the force between the lithium and chlorine, or the lithium ion and chlorine ion. So it easily they're gonna separate. So in that case, these ions will separate. We have separated lithium ion and separated chlorine ion. And then we're gonna find that each ion will be surrounded by water molecules, which prevent these ions from rebonding one more time. So like this, it keeps suspended or uniformly distributed between the water particles. In that case, we call this already the substance is dissolved. So here that the idea that's happened in that case. So actually, sometimes we find that there are uh, some compounds in their structure they already keep some water in their structure, and we call them hydrates because actually the water, the idea of dissolving by using water or breaking down by using water, we call this hydrated. Okay, so some hydrates, they are chemical substances already their structure contains some water which is arranged in a certain pattern in their crystals or in their formation. Like for example here copper sulfate hydrates, okay, or the hydrate of copper sulfate, CuSO4.5H2O. Actually these five water molecules, they are just we call it the hydration water. This hydration water, it's make okay just like this kind of circle on the structure around the copper sulfate. So what happens when hydrates are dissolving? Actually, once we dissolve hydrates, they act like non-hydrous crystal. That means once we put this substance in water, the water of hydration will return back to the solvent or the water, and then okay the crystals of copper sulfate is going to dissociate or break down with the same manner like what happened in lithium chloride state as we explained before. So here like this, whatever hydrate or non-hydrate substance, both of them they are gonna follow the same manner during dissolving. In another hand, we find if we get this ionic compound like lithium chloride, can it dissolve in non-polar solvents like like for example carbon tetrachloride or toluene? Actually, it will not dissolve. Why? Because here in that case, these two they are non-polar. The opposite charge, which is already allowed this kind of separation or dissociation to happen already in lithium chloride, is not found anymore, which makes the lithium chloride cannot dissolve anymore. So here that the idea, guys, which represent that not all solvents can dissolve in solutes, not all solvents can dissolve all solutes and vice versa. Thank you, guys, and that's our part which we're gonna step at. So please study this part very well from your textbook, and if you have any questions, okay, I'll be happy to hear them soon. Thank you, guys, and goodbye.